Programming languages often have some mechanism for indicating that an error or some kind of exceptional event occurred, and then a mechanism for handling those errors and describing what to do next. In Python and many other languages, those are called exceptions. You can raise an exception to indicate that something exceptional has happened, like an error has occurred. Python exceptions are raised with a raise statement that says raise and then has some expression which evaluates to an exception. This expression must evaluate either to a class or an instance. The class has to be a subclass of a base exception, which is something built in, and the instance has to be an instance of some kind of exception class. Exceptions are constructed like any other object. So there are different classes, many of them built in, such as type error and name error. And then to build a particular type error just involves passing in a string that describes what happened. So here's the kind of error that occurred, and here's the specific detail. And there are type errors that are commonly raised when a function was passed the wrong number or type of arguments. Name errors are raised when a name wasn't found, a key error, when a key wasn't found in a dictionary. There's even a recursion error when you make too many recursive calls. So all of these error types are built in. These exceptions get raised automatically in certain settings, but we can also raise them ourselves. Let's check it out. So in Python, if I take the absolute value of 3, it's not an error. But if I take the absolute value of hello, a type error has been raised. It says type error, bad operand type for abs stir. It turns out that I can also raise a type error anytime I want. Now this type error doesn't have a description, but if I raise a type error with some message, such as very bad idea, then that's exactly what I'll see in the message. Therefore, I could write my own function, double x. If it's the case that x is a string, then I might want to raise a type error. And I can describe it however I want. Double takes only numbers, or whatever. And then I'll return 2 times x. Why would I ever write such a thing? Well, 2 times hello does work in Python, but if I want my implementation of double not to work on strings for some reason, then I can double 4 and it works fine, but when I double hello, it doesn't work. It says double takes only numbers. The other kind of errors that are raised automatically are, for example, a name error, a key error, and a recursion error. When I call f, it calls f, which calls f, which calls f, and reaches a recursion error because I have too many recursive calls. The reason that exceptions have types is both to help describe what happened when you see an error message, but also to create the capacity in the language to handle exceptions and continue running the program. By default, if an exception occurs, the program halts, shows an error message, a traceback, and then it's up to the programmer to figure out what they want to do next, change the program, and run it again. But maybe you want to write a program that keeps going even after an error occurs, and the way to do that is to use a try statement to handle exceptions. A try statement has try, and then some block of code, anything you want. And then paired with the try is an except line. You can even have more than one except line. And the except describes a particular class of exceptions that are handled by this try statement. You can even give a name to the exception itself. And then there's a suite, which is a block of code describing what to do when this kind of error occurs. The way try statements work is that the try suite is executed first. If there's no error, it's done. But if during the course of executing the try suite, an exception is raised and it's not handled otherwise, And if the class of that exception inherits from the exception class that's described here, then the except suite is executed, and the program doesn't necessarily halt. If the except suite just says, print out an error message but keep running, that's exactly what will happen. And the role of this name is to give a name to the exception object, which sometimes is useful because then you can print it out. Exception handling can prevent a program from terminating. So if, for example, you say try to divide 1 by 0, but you accept that if a 0 division error occurs, you don't want to have the program halt, you just want to print out that it's handling a 0 division error and assigns x equal to 0 after that, then x will be bound to 0 even though this line appears later than this line in the program, which raised the 0 division error. So this is displayed because of this print call, and this assignment is because of x equals 0, and we never saw any kind of multi-line traceback because the exception was handled. So let's try out another example. Here's invert, which is a function that takes x. It computes the result, 1 divided by x. Now if x was 0, then this line will never be printed, right? Because it'll never get that far. And then let's have it return the result. This program's just fine. I can invert 2 to get 0.5, and this is printed because x was 2, not 0. But if I invert 0, then an exception is raised, this was never handled, and this line was never printed. But then I can write another function, invert safe. And what invert safe is going to do is take x, but then try to invert it. So it will try to just return the result of inverting x. But in the case that there's a 0 division error, we'll give that error a name e. And how about we would just return a string version of e? With invert, if I say a equals invert 2, then a is defined. But if I say b equals invert 0, then b never gets assigned at all. But invert safe is different. If I say a equals invert safe 2, then a is bound to 1/2. If I say b equals invert safe 0, then there was no error displayed. b was instead assigned to the string division by 0. And why did that happen? Well, that's what the code says. It says try to invert x. If it doesn't work out because the 0 division error was raised, then invert safe should not cause an error to be bubbled up until the program halts. Instead, it should handle that error right here and return a string instead. And if instead of returning that string, you had it return the number 0, then we get even different behavior. A would be bound to 1/2, and b would be bound to the number 0, because that's exactly what invert safe returns in the case that inverting doesn't work out. That's how exceptions work. And they're particularly useful when your program is handling input from a user or from the internet that might not be the right format or might not have the right properties. And so errors might occur, but you might not want your program to just halt. You might want it to just, print out the error and keep going, or use a default value, like in this case.